Hello everyone, in this class we are going to talk about logic gates and combinational circuit. We are going to divide the lecture into several parts, just like the name of the lecture. They include logic gates, digital components, and combinational circuit. Okay, what are logic gates? As you know, electronic components including resistors, capacitors, and transistors. Using this electronic component, especially include the transistors, people can create a circuit that can have the following functionality. If having two of the input both of them being low, then the output is low. If having only one of them being high, then the output is also low. If both of them being high, then the output is high. Such a circuit is called an AND gate. So basically, each of these gates means a little circuit made up of several resistors and the transistors. But actually, in this lecture, most of the time, until right now in history, people use this symbol to represent the logic. This circuit, we call it logic gates. A circuit that has such functionality is called AND gate. The circuit that has the functionality like this is called OR gate. The circuit can flip the value of the input is called NOT gate. So we have three basic gates. For the truth table, there are also other possibilities. If the circuit are implementing this, we call it XOR gate. And if the circuit is implementing this kind of functionality, we also give it a name called NAND gate and NOR gate. In total, there are 6 different logic gates. Most time we talk about it in electronics, and these 8 gates are listed in the PowerPoint, and also their names are here: AND, OR, NOT, XOR, AND, and NOR. We call these 2 universal gates, even though the first 3 are the basic and the easiest to understand, but these 2 are called universal gate. The reason is that we can use the universal gate to compose any kind of gate. For example, on this slide on PowerPoint 7, if we connect the an AND gate like this, it means an AND gate. If we connect the AND gate like this, then it is an OR gate. Talking about logic gates, we can have 2 input as we showed, or 1 input as the NOT gate. But we can also have more input, such as 3 input, and the result output can be either the multiplication between the variables, or which we consider are the and between the different input, and the OR between different input. In Boolean logic, we use 0 and 1 to represent the variables, and we can write a function out of the variables, such as this one. The function f has the input x, y, z equal to x plus not y and z. So x or y, not y and z. Okay, and in digital logic, we can use a logic gate, which means we can connect a circuit to do this calculation automatically. The way to connect circuit is going to be like this. Firstly, we add a NOT Y. We add a NOT gate in front of Y, and then we connect with Z using the AND gate. The result of this are connected with X using the OR gate. This circuit can automatically generate result for this function. Because of we mentioned using the NOR gate, using the NOR gate or AND gate, we can create any kind of gates. We can achieve any kind of circuit. So people invented a IC package like this, where embedded several different gates like this. Then by hooking up wires outside, we could create achieve goals such as creating some output based on the input. What I mentioned is like the example is here. If we have an IC packet like this, having the gates mounted on the chip like this, then if we want to create a circuit which has the output function value equal to NOT X and Y, then we can connect the wire like this. If the input of XY is here, by connecting the circuit like this location 8 is going to get the result of NOT X and Y. As Boolean logic is used to solve practical problems, and the truth table actually is a realization of a Boolean function, we can actually also use circuits to represent the truth tables and the Boolean function. We can create a digital component, which means a logic circuit, to automatically do the decision mentioned in this story. At the end, we can create such a digital component to have X and Y as the input, and X and Y being the output. Okay, from this slide, we start to talk about the combinational circuit. When the logic gates are created, we can connect them to fulfill some functionality. I have a little notes here. For circuits, there are two kinds of circuit. One is called combinational circuit. The other is called sequential circuit. For combinational circuit, the meaning is that the output of the circuit is delivered directly from the input. Examples including adder, encoder, multiplexer, and shifter. Sequential circuit means that one of the wire already has a value, 1 or 0, or say high voltage or low voltage. At the time the clock triggered the input provide value, the output is going to change the value or not, based on not only the input but also the output wire itself. This kind of circuit are called sequential circuit. Okay, as we mentioned, there are two kinds of circuit, two new names. One is the combinational circuit and the other is the sequential circuit. We are going to go over quickly about the combinational circuit. The most important combinational circuit in history is the adder. The adder was also invented by the same guy who invented the logic gates, Claude Shannon. As we know, for adder, we are doing modulo 2 adding. We want a truth table like this, and we call this, if there is a circuit could implement this, it is called a called a half adder. And in this half adder, if we also want to include another input, which might be the carry from the previous digit, it could be drawn as a circuit like this. So here we have learned one kind of computational circuit as the half adder. If we make this to be more complicated, as this is the half adder, we can implement it to be a full adder, which means that the half adder show the sum but couldn't show what might be the carry out. The full adder can calculate the sum and also show the carry out. If we add several full adders together, like this, each FA means a full adder, then we can create a circuit that is doing calculation on more digit adding. And this kind of adder is called a ripple carry adder here. Okay, so if we stop here, the first combinational circuit we see is the adder, and there are three kinds. Originally, people invented half adder. Later on, they invented full adder, and several full adders putting together is the ripple carry adder. Other combinational circuit include decoder. Okay, what is the meaning of decoder? The decoder has several input and several output. Normally, the number of input, if it is n, then the number of output wires would be 2 has the exponent of n. Okay, the decoder circuit should look like this. If we try to understand this better, if x and y are zeros, then the wire here would have not 0 and 1 would be 0. And here, so if here is 0 and 1, this location is going to be high and all other locations are going to be low. If here is 0 and 0, this location is going to be high and all other locations are going to be low. So each time when here is supplied by one value, one of the wire is selected. And we consider this, give it a name as decoder, which means that if you have 0, 0, which is decoded to be 0, so the first line is going to be selected. If you have 0 and 1, which is decoded to be 1, the number 1 where is going to be selected. If you have 1 and 1, which is actually 3, the third where is going to be selected. If you have 1 and 1, it's going to be the last, the fourth where being selected. And this circuit is called a decoder. For combinational circuit, we are going to mention, including decoder, 3 other different circuit. The decoder is one, the multiplexer is the opposite of decoder. Here, if we have the input as 0 and 0, it's going to output the value of I0 to the output. If it is 0, 1, then it's going to select the I1 to the output. If it is 1, 1, it's going to select I2 to the output. If it is, if 1, 0, it's going to select the I2, and it is 1, 1, it's going to select the I3 to the output. A multiplexer does just the opposite of a decoder. And a 4-to-1 multiplexer look like this. The inside will look like this. The last kind of combinational circuit we are going to cover is the shifter. And in this diagram of the circuit, if S is 0, it means, so whether S is 0 or 1 determines to right or to the left do we shift this digit. Well, for example, if the input is having some numbers, then whenever we create the value as also here, the output is going to be a shift of the input value, either to the right or to the left, depending on the value of S. Okay, so until now we have mentioned several different kind of combinational circuit, include the adder, the encoder, multiplexer, and shifter, 4 kinds. At the end, we mentioned that so in the area of circuit design, we have 2 kind of different circuit. The one we introduced in this slide, in this section, is combinational circuit. There is also the type of sequential circuit. As we mentioned at the beginning, combinational circuit create output value based on the input value, and the sequential circuit create the new output value based on the old output value and the input value. Okay, that's very easy to distinguish. We are going to cover about sequential logic circuit soon later.